So linear probabilistic modeling, what is it? It's using linear regression to find binary probabilities. So it's using a linear trend line to model situations that only have two possible outcomes. The formula y, the dependent variable, it's the probability of y being 1 or a success given x factors. Beta naught is the probability of y being 1 with absolutely no other factors. Beta 1 x is really what we're counting here is the scaling factors. Beta is the slope coefficient and x is the actual independent variable, and then the error term at the end is just how far each of the points are going to differ from the trend line that it makes. So here's kind of a visual representation. I just want you to notice that it says beta 1 plus beta 2 x, meaning that there could be multiple factors going into each independent variable x. So there's three constraints to LPM. One of them is that it gives probabilities outside of the acceptable range 0 to 1. We saw this with linear regression last week with the negative body weight example. The second one is heteroscedasticity. I think I said that right. It's when you have different samples coming out of different populations with varying variances. And the third one is non-normality. So these are the three constraints. And to move on, I wanted to go to engineering application of LPM. I'm an industrial engineer, so we focus on optimization and process improvement. So I wanted to use LPM and analyze line efficiency in a supermarket. So to make it binomial, I have a success if a person waits less than 5 minutes in a line, and a failure if they wait 5 minutes or more. The goal of this whole thing was to minimize failure or to get customers through the line quicker. And to make this really simple, the only factor I wanted to use was how many lanes were open. So I made this data, number of lanes open on the left, I have n equals 10 customers for each scenario on top. So A through J, 10 customers would go through with 0 lanes open, 2 lanes open, 4 lanes open, and so forth. And as you see, 1 is a success, 0 is a fail. And this was the linear trend line that came from it. Basically, all you need to see here is that with more lanes open, the probability of getting through the line in less than 5 minutes goes up. And if you look closely, you see that it actually goes to 100% at 9. So you wouldn't need this 10th lane open. That could be something you find out from this study. And this is just the simplest example possible. So really, what should be happening is this should not only be the number of lanes open, it should be the time of the day of the week, how many items per cart, the number of lanes open. They could all be beta 1, 2, 3, 4, and be represented by the independent variable x, all affecting y. But this is just the simplest example to show what you could do with LPM. So really, in conclusion, LPM is not the most unbiased estimator for a data set because of their constraints, but in the big picture, it can be utilized as the perfect first step in an analysis. Thank you guys.